Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Okay guys, so after understanding about what is Kubernetes and why Kubernetes, now we need to understand how Kubernetes works. That's important. Okay, because if you understand that how Kubernetes works, then you will understand that how Kubernetes can help you in many things. The benefit which we talked about it, all the stuff, so it will be validated. So as part of this, you need to understand the big picture view, master, nodes, board, services, deployment, and many more. So let's understand the big picture view first. Now think about it. Kubernetes is a container orchestrator also, and Kubernetes is an orchestrator for microservices app also. Okay, also. So it's a container orchestrator also and microservices orchestrator also. So now question is, what is microservices and what is the orchestrator? I think many of you must be knowing about what is microservices, but for let's say someone who's not having greater information about the microservices, I'll just add just a few lines of it. So earlier our software architecture was designed on a monolithic concept. Monolithic means every feature, let's say software has 100 features, right? So all these 100 features will be added in only one product, only one package. That was called monolithic. So monolithic model was very popular in case of desktop-based application. Like MS Office, we install that's a monolithic. Everything is you have in the one package. But when internet comes, we started using the internet-based application. Then we got a service-based concept of architecture. Service-based architecture means web service you run separately, batch service you run separately, database service you run separately, because of so many reasons: scalability, availability, security, this, that and all. Okay, because of that you were accessing the application through internet. So that's SOA concept. In the today's world, we are moving into the microservices world. Microservices world, that means you want to have everything now. Okay, everyone should be doing everything. Like that's called DevOps, right? So you should be doing programming also, you should be doing testing also, you should be doing operations also. But how can you do it with such a vast software? Then people started migrating to microservices. So let's assume this is the one software, okay? And this has hundreds of features. 1 feature, 2 feature, 20 feature, 30 feature, 40 feature, 50 feature, right, like that. Okay. Now you have 100 of people is working for this particular product. Okay. 100 people are working for this particular product. Now what we do in this case? So we'll convert into microservices. So this service will separate it out. This feature will separate it out. This feature separate it out. Now, think about it. Earlier, this product was being managed by hundred of people. Okay. Now, how many, and the size of the product was 1 GB, let's say, 1 GB. Now, what is the size of the product? Let's say 10 MB, 5 MB, 10 MB, 5 MB, 20 MB, like that. How many people are working now? 2 people, 3 people, 1 people, 2 people, 3 people, 4 people. Okay. So now, you see, you have 2 people in this particular microservices. So now these 2 people, you have to code also, you have to test also, you have to plan also, you have to release also, everything you have to do. That is called DevOps. Okay, that is called DevOps. So here, this is called microservices. Now, in the world of microservices, if you look at any product, number of microservices, you have 200 microservices, 300 microservices, 400 microservices. Now the question is, everyone will manage their own microservices. Who will manage all microservices? Think about it. Who will manage all microservices? Who will decide, okay, if this is a login page, from the login page you should come here. If it is a registration page, from here you should come to the login page. Like that. Who will decide? Okay. This is a dashboard. This is a account. This is my profile. Who will decide? This transaction, who will decide? And here you don't have 1 or 2, you have 200 microservices. So guys, did you understand the problem here? Too many microservices. Who will manage it? Who will control the communications? Did you understand that? Hello?
Yes.
Yeah. So guys, that is where I am talking about. Kubernetes can do that one also. Kubernetes, an orchestrator for microservice apps. Yes. Kubernetes, an orchestrator for microservices apps. That means, too many microservices you have, who will manage it? Kubernetes. How? Let's understand. Look at this here. This is the football ground. And we have a team and the manager and coach. Okay. Now, we have a team. So, any idea what is the objective of the team in the football ground and football team, soccer team? What is the objective? Anyone would like to comment?
To score.
Are you sure?
No, everyone will have their objective, right? So,
Yeah. See, typically in you might have played football in childhood days, right? I played till 12th actually. I played a lot, to be honest. And our objective every day, whenever we go to the field, right, to play football game, our objective was to make a goal. That's all. So when you have an objective to make a goal, then where you will be? Near to goal post. And when you have a objective to make a goal and you will be near to the goal post, do you think you will be able to win the game? No, right? Because everyone will have the objective to make a goal and everyone will be near to the goal post, and so you know what will happen. So that is how we play. So now remember here, each team member has a certain quality, certain distinct qualities. Someone is good in something, someone is good on some other thing. But everyone has something good in everyone is good at something. So that is where the manager, aka coach, aka master comes into the picture, and they say, boss, listen each one of you. I know each one of your capability. I know what you can do, what you cannot do, what you can do good, what you cannot do good. So, if you follow me, if you follow my guidance, and if you do the way or whatever I say, then only you can be on ground. If you disobey me, then I will throw you out of the ground. And that is where the discipline comes, right? So these players are having lots of good qualities, but without a manager, without a coach, without a master, these are not effective. So manager comes into the picture and then everyone started being in line with the game. So now here you see here. Now as per their roles, as per their expertise, manager plays each one of these at the football ground and they've been instructed, do not run. Because you cannot run faster than football. So just coordinate. Between each player, you just coordinate and pass the ball. And those teams who coordinate well will win. You know that. You might have been following the World Cup, right? Many times we have a surprises like you were expecting, okay, this is the best player you have in this particular team and they will win for sure. And finally suddenly you got to know like the teams which was having the best player did not even score 1 or 2 goals. But those teams who played well, coordinated well, they win the game. Right? So this is what it happens. Why it has happened? Because of manager, because of coach, because of master. Now replace this all players and their capabilities with the microservices. Replace. You have an image in front of you. In your mind, just replace. These are not a striker, defense player, but these are the microservices. And microservices what they pass to each other. Request and response. You know that. Each microservices will receive some request and provide some response to each other. And that is how that one end request will be served. Let's say you want to log in a website. So few microservices will be activated. One will be validated. One will be redirected and this, that, and all kind of thing. So now all this request and response control is done by what? In the world of containers with the help of Kubernetes. Kubernetes will do that all the stuff. So see here, each one of these players convert into the microservices app, and all these microservices have certain protocol to communicate for the communication, request and response. And all this thing is being managed by Kubernetes. Interesting thing starts getting started here. Look at this. Look at this image. So here if you look at this image, you have a different kind of microservices. You have a same kind of microservices, but running in the different machine, but the behavior is still same. Here, HTTPS is running on the node 1 and same HTTPS microservices is running in the node 2, but the behavior is still same. How come? Because of Kubernetes. That's the reason we say Kubernetes is an orchestrator for microservices apps also. Kubernetes is an orchestrator for the containers also. That means if you want to bring the containers to the production level, Kubernetes is the solution for you. Guys, everyone is clear for this?
Yes.
Okay, so now the question is what is the architecture? How Kubernetes works? So guys, in Kubernetes, look at this image please. In the Kubernetes, you have a cluster. What do we call it? Shared cluster, Kubernetes cluster. In the cluster, what we have? Look at this very carefully. You have a master, the same master which was managing your player. Master, aka coach, aka manager, whatever you want to call it. You have a master. And the master manages multiple nodes. These master and node, it can be physical machine, it can be virtual machine. Mind it. This node is nothing but a virtual machines or physical machines. Master is nothing but a virtual machines and physical machine. But you might be seeing here, you have a multiple master. See, behind that there is a shadows of the master images. So guys, see, without the master, cluster will not be able to function. So if one master is not well, you have to have a different master also who will take care of this your cluster. So yes, for the sake of production, for the sake of the well functioning cluster, You may have a multiple masters also. Typically, we create a 3 masters, active one at a time, or you can make active all 3 at a time also. You have to work with some of the configuration. Okay. So in short, in the Kubernetes cluster, you have a master, you have a node, you may have a multiple master. Now, who controls the master? So you might be seeing in the image, there's one file. We call it a package, deployment package, right? So that file is being sent to the master, and master receive that instruction, and master control entire cluster. Now the question is, who's writing this file? Any idea who's writing this file? Any idea? Yeah, you will be writing this file. So guys, for your information, your job is nothing but to write that file. That's all. Your job is nothing but to write that file, send it to master and forget about it. That's all. So here, this is the architecture. Let's deep dive into this. Master who is in charge of getting all the tasks done. Real task is done in the worker node. And you send the deployment to the master. And now in this image you see, if you look at this very carefully, deployment package is being sent to master. Master who's in charge of node. You have a multiple node who's doing the work for you. When I say work means container is running in the node. When I say do the work, that means container. Understand that. So containers is running in the node. But if you look at this image very carefully, node has pod. Look at this very carefully. Node has pod, and if you look at the pod, the sign which you can see is of container. So when you want to find out the architecture, you have a Kubernetes cluster. Cluster has a master. You may have a multiple master for HA. Master control node. Node, you may have a multiple node who's real doing the work. When it do the work, container is running in the node. But here interesting thing is, in the Kubernetes, node has a pod and pod has a container. Container is not running out in the node, but container is running inside a pod. And pod is a part of the node. So mind it. Remember these points. If you want to run a container in the node, you have to keep the container inside a pod. And you run the pod in the node, not the container directly. Now the question is, what is a pod? Because you know the container, what is a container? But the question is, what is a pod? I will explain you little bit later. So far so good, guys. Any questions? Any doubts?
Node can be any host machine, like it can be Linux, Windows.
Yeah, so any flavor of Linux, and in fact nowadays it can be Windows also. Windows 2019 plus.
Is it a one-to-one relation between?
I think someone is asking some question, but I am hardly able to hear him.
Is it a one-to-one relation between node and pod?
No. I'll complicate this architecture little bit later. But here master manages the nodes. Node has a pod. Pod has a container. That is there so far. Let's move on.
What does that pod mean by any abbreviation?
So that's what I said. This is at the high level, okay? I'm not complicating right now. What is a pod? I'll deep dive into that in some time. Give me some time. So guys, let's focus on the master. So master we also call the Kubernetes control plane. Okay? Master we also call the Kubernetes control plane. So guys, here if you look at this, master runs on the Linux always. Okay? And node also, earlier used to be Linux only, but nowadays it's a Windows also. So this image will need to add some addition of the Windows icon also. So master manages the node. Master manages the node. Master has a 4 component. Master can be multi-mastered HA also, high availability. Master manages the node. Understand that. Master manages the node. Master has a 4 component. If you look at the inside the master. Now look at this here. Node has a pod. Look at it very carefully. Node has a pod and pod has a container. One more perspective. Node may have a multiple pod. You see that right hand side. And if you look at the left side, top one, node have a pod and pod may have a multiple container. Understand the scenario? Okay. In simple way, master manages a node where the container runs, but container runs inside a pod. And pod, you may have multiple in the node, and inside a one pod, you may have a multiple container. Guys, are you understanding this image well?
Yes.
Yeah. So please understand this. Let's move on. So guys, let's discuss now. Let's focus on the master only. Master has a 4 component. Master has 4 component. First component, we call it API server. Okay. Master, I'm focusing only on the master right now. Only the middle one. So master has a 4 component, and the first component what we have is API server. Now the question is, what is API server? Let's read it. Let's read this. So here, if you look at it, API server is the front end to the control plane. When you say control plane, master, we call it control plane also, right? Control plane or master, both are same. So, what is the API server? It's a front end to the control plane. It exposes the API, REST API, and consume JSON file. Okay. This consume JSON file. Please read it one more time. Okay. So now let me simplify that. These are the official keywords. I want to simplify for the sake of your better understanding. See guys, there is a 2 keyword. There is a 2 keyword. One is API, and I assume you all know what is the API stand for or what API means for. Okay. So API is the application programming interface we or human or program. This is a program. This is a program or human connect to get this feature done. To get this feature done. There is a feature written, some feature, some functionality, feature, whatever you want to call it. So we connect or program connect to API to get the feature done. But here I am talking about API server, right? So that means there is a multiple API here. Multiple API, 1 API, 2 API, 3 API, 4 API, 5 API, 6, 10, 100, all these API. And here we have created API server. So now if you want to access not only one API, but if you want to access any one of these API, you talk to this API server. So now did you understand that what is the meaning of API server? API server is a collection of functionality which you have available at one place, and any functionality which you want to get it done through the Kubernetes, you will connect and you will instruct API server. That is the reason we call it front end to the control plane. Are you understanding this? Are you understanding this?
It's like a RPG gateway or something like that.
A gateway is just to pass the request, right? But API server is hosting all the functionality. It's a hosting. Are you getting my point?
Okay.
Okay. Now guys, second component which we have is cluster store. Second component which we have a cluster store. Please read this and then I will explain it. Cluster store, persistent storage, cluster state config, uses etc distributed, consistent, watchable, the source of truth for the cluster, and have a backup plan. So what is this cluster store? So basically guys, in the whole Kubernetes, this is the only place where you store something and which will never get deleted, and that is cluster store. This is persistent storage for the cluster. Yes, cluster store is a component which is located in the master node, which is their job is to store all the information permanently. But what kind of information? State of the cluster and configuration of the cluster. In short, any state and configuration, it gets stored in the cluster store. Now you must be thinking, okay, fine, but what technology they use it? Is it a MySQL? Is it Redis? It is what? So basically guys, cluster store is powered by etcd. etcd is open source free software, again available freely. So you can check it out, supported by CNCF organization. Okay. So cluster store, where you store the persistent storage and which store the cluster state and the configuration, powered by etcd, and whereas the etcd is a distributed. When it's a distributed, that means can run in themselves in a multi-cluster node. And it's a consistent, watchable, you can watch it from any node. And this is a source of the truth for the cluster. That means anything which you have in the cluster store, it's available in the cluster. If it is not available in the cluster store, it's not available. That means, and you have to have a backup plan for it. Okay. So now let me try to simplify this. Okay. So now let's check it out here. Face. See here. This part is a control plane for your body, correct? This is your control plane for your body. This part is controlling entire body. Now, from where you can send the instruction to this body? So, the instruction comes from here. So, this can act like a API server. Now, if something you have heard, you will definitely store it. Where do you store it? Memory. This is kind of API server. Cluster store. Okay. So this is a API server storing in the cluster store, memory. Are you able to correlate? Are you able to correlate?
Yes, sir.
Now you tell me in this control plane for the body, which is keeping everything getting updated, keeping everything monitored and updated. Which functionality? No. In this image, which is a control plane for the body, which is informing you everything about the real world.
Eyes.
Eyes. How many eyes do you have? How many eyes do you have? 2, correct now? 2 eyes. Okay, great. Now, just back to the discussion. Guys, after the cluster store, you have a controller manager. Understand that? What we have? We have a controller manager. Third component. Now please read this and then I will explain it. So, controller manager is a manager for multiple controllers such as node controller, endpoint controller, and namespace controller. Now you know what each controllers are doing? Each controller is watching. It's your eyes. It's your eyes. He's watching for the changes and informing. Look at the arrow in the image. Controller manager, the image says controller, but actually it's a controller manager, okay? So controller manager has a multiple controller and each controller is watching something and informing to what? API server. Look at the arrow. An API server stores that information in the cluster store. So if you take that way, so your eye is monitoring. See here, you got the instruction from through ears, stored in your mind. Eyes is monitoring and updating the realistic picture about whatever you heard, because you hear anything, whatever you've been told, but you can see only the realistic things, right? So you see that, and whatever the observation you see, you also store in this. So there is a two. In the memory, there are two things. Understand that. Very simple concept. In the memory, whatever you have heard and whatever is just you have seen, experience. Two things. So whatever you have heard, that's called desire. And whatever you have experienced, that's called actual. Both the things where you have cluster store. And these two things together forming a controller manager. Are you able to correlate? Right? Are you able to correlate?
Yeah.
Now last component of the master. By the way, controller runs always in the loop, never stop. If controller stops, you are dead. That means you are sleeping. Last component for the master is Cube Scheduler. Okay? Scheduler. So guys, Cube Scheduler, what is doing? It watches API server for the new code. That's a technical definition. Look at the arrow also. Scheduler keep watching API server. And if some request, if it gets from the API server, it assigns work to the node and had affinity, anti-affinity, constraint resources and all. Let's understand it. This is your controller manager. This is updating the actual. API server updating the desire. Now, your mouth will act like a scheduler. See, this is not doing any work, but just scheduling the work to someone else. So you are telling to someone else, do this, do that. It's like that. But if you tell, let's say you are the manager and you are assigning the work only to the one engineer, that's called affinity. But you will say, okay, anyone who's available, do that. Then that's called anti-affinity. Anti-affinity means you are not affinity to anyone. You can get this task done any available resources. Okay. So here that is what I have been talking about. So here scheduling is the fourth component of the master node, which basically keep watching the API server and based on the request from the API server assign the work to the node. And when I say work, always remember it's a container only, which is in the Kubernetes inside a pod. Understand that? Okay, so that's the reason it says watches API server from new pod. Assign work to the node, affinity, anti-affinity, constraint, resources. So these are the four components, and all these four components coming together and they are being called as a master. Guys, did you understand this now?
Yeah.
This is called master. Now I am going to explain you in short official keywords what is master. Master is also being called as a control plane and the components are four primarily. Okay, there are few more add-ons are available which I am not discussing as part of this program, and the reasons are not want to complicate everything at a one point of time. So guys, what is the API server? API server is a central. It is a simple RESTful API and it updates the etcd. Cluster store, which is the persistent storage, stored in the key and value format, powered by etcd and you can watch it. It's watchable. Scheduler watches the API server for scheduling the pod, resource and resource contents along with it. Controller manager, which always runs in the loop, help you to manage the life cycle of and desired state and actual, watches and update the API server of the current status, and replica set, which I'll talk about a little bit later. So overall, look at the architecture, little bit complicated. Now look at this very carefully. You have a four component in the master node. Scheduler assign the work to the node. Node has a pod. Pod has a container. And now who's assigning the work to the API server? Look at this. This is very important. Very important. Look at this. Who's assigning the work to the API server? Your laptop. Laptop has what? kubectl. How you send the request? In form of JSON. It can be YAML also, by the way. Okay. So it's like this. So this is the little bit elaborated format of architecture. Are you comfortable with this image? Guys, are you comfortable with this image?
Right here. What auth will do instead of?
Auth means see. Anything you send the instruction to API server, they will see in the cluster store. But only authorized people should communicate with the API server, right? Not anyone can send the instruction and anyone can and a cluster will start doing their work. No. Only authorized person should be able to send that instruction in form of JSON or YAML, right? So that is where authentication and authorization you have it at API server level only. Got it?
Yeah.
More questions, guys? Okay, let's move on. So guys, now let's talk about the nodes, minions. Okay. And we also call the Kubernetes Worker. Whatever you call it. These are the VMs or virtual machines, physical machines. You can call it nodes. You can call it minions. You can call it Kubernetes Worker also. So we need to understand. So guys, have you watched this movie called Minions? Can you please tell me how many of you have watched this movie Minions in the chat box? This is a movie I'm talking about. Okay. So I see that 4 votings are there, 4-5 votings. So if you have not watched this movie, you must watch actually. Very good movie. I think we have two release of this, 2 versions. So guys, anyone would like to share with me the story of this movie? Anyone? In short. Krishna, you want to take up the lead on this? Naresh? Vidya? Anyone?
Yes, Rajesh. They are searching for the executable masters to them.
Right, yes. Correct. So guys, I'll tell you the story of the topic. So what is happening in this movie? Minions are one of the species, okay, who cannot live without a master. Master, I said, please hear this story very carefully, okay? Each word you have to understand that. So minions is a kind of species who cannot be happy, we cannot be good without a master. So one fine morning they get up. They get up. I repeat multiple times many statements, so please find it. Minions gets up, look for the master. Minions gets up, look for the master. They do not find the master, they become sad. Then some of the minions decided to search for the master. Somehow they found the master. Minions beg a master, saying that, master, please, I want to be your minion, I want to be your slave, I want to be your worker, please make me your slave, make me your minion. Master here approves. Understand that. Master here approves, saying that, okay, you are my minion. Then minions become a part of their worker. If master is not approving, then minions cannot be a part of the worker of this master. Understand that. The moment master approves that, say, okay, you can be my minions, you can be my slave, you can be my worker, immediately minions start bugging master. Same time. Bugging master with what? Master, I am alive, I am healthy, I am this, I am that. Please give me my work. I will do that for you. I will do anything for you. But the problem with the master is master will have work only if they have some genuine things to get it done. So minions will keep bugging master, but master will give the work only and only if they have it. If minions will receive some work from the master, minions will do blindly, and immediately again report back to the master saying that, master, I have completed my work, please give me more work. I have this much of CPU, I have this much of capacity remain left. And this is the kind of story which keep on running in the animated way. Though in the movie, minions kill master in some accident, and they have some interesting climax also, some climax in very good movie actually. Okay. So, but overall the story is like this. Minions gets up, look for the master, get approval to become a worker, master approves it. When the moment master approves it, minions keep bugging, master give the work, minions perform the work, and then this is how the relationship between the minion and master is surviving, and that's how you got a 2 series of this movie. Okay, there are some adventures also. Please watch this. So now the question is, why we are talking about here. We are talking about here because this nodes, aka minions, aka Kubernetes workers, the behavior is same, 100% same. Here, minions have, workers have, nodes have three important components. On first of the component is Cubelet. Can you please read this? I will tell you. What is a Cubelet? Remember, in the laptop you will have a kubectl, the one which I showed you earlier. Don't get confused with it between the kubelet and kubectl. Even I used to get confused for 3-4 years before. Kubelet is in the node, kubectl in your workstation. So what is the job of the kubectl? Kubelet? It's a main Kubernetes agent, register node in the cluster, what is API server, instantiate a pod, report back to the master, and it is accessible with exposure as 10255. See here. Kubelet is the real minion actually. Kubelet is the real minion, aka worker, aka whatever you want to call it, agent. So Kubelet, the moment you run the Kubelet, minion gets up, Kubelet run. Minions look for the master, Kubelet look for the master's information in the configuration file. Kubelet requests the API server to become a master, become a worker. Minions also request the master to become a worker. API server approves it to Kubelet through certificate. Master approved to the minion through certificate, through approval. The moment masters approve, API server approve, register node with the cluster. After that, Kubelet keep bugging API server, watching API server, saying that I have this much of CPU, this much of RAM, this many pods, this many containers, this many this. Keep updating themselves with the API server and asking for the job, asking for the more work. But who will assign the work to the Kubelet? Any idea, guys? I forgot the name actually. Who will assign the work to the Kubelet? No. API server ultimately, but through? Yes, guys. Scheduler assigns the work to the Kubelet through API server, and after that, Kubelet will do the work, report back to the master, and it is accessible on 10255. So this is a Kubelet. The main Kubernetes agent has to be running. I said has to be running in the each node and approved by API server to become a part of the worker family. Okay. Second component which you know very well, and I'm not going to talk about it, you're going to read it. Here this can be Docker also, it can be Rocket also. So that's the advantage of Kubernetes actually. You can, if you don't like a Docker, tomorrow you can use anything else such as Rocket, Podman, and many technologies are there. So you can use that. Okay, so container. Guys, third problem, before third component I am talking about, look at the networking requirement. And this you have to read it and also understand this. I'll give you a few seconds. Please read this. Okay. So guys, networking requirement, remember the problem with the container technology, we discussed a lot, right? So problem with the container technologies are, how can we make the container accessible to the load balancer? Because Docker was not supporting that. So we need some solution, right? The solution is, in the Kubernetes, you know that container is inside a pod. What is a pod? We don't know. We need to discuss on this. But one thing we know that pod is inside the node, and in the one node you may have a multiple pod. Inside a pod, you have a containers. Inside a pod, you may have a multiple containers. We know that. So, the pod, all pods can communicate with each other on the all nodes. That's the networking requirement in the Kubernetes. All nodes can communicate with each other, communicate with all the pods, and no NAT. How can it be possible? And that is possible because of the third component of the Kubernetes node. We call it kubeproxy. Kubeproxy. So guys, kubeproxy is the third component of the node, and this is your networking services. Kubernetes networking services. Kubeproxy assign IP address. Understand that? Kubeproxy assign IP address to the pod. Yes, here container do not get IP address. Again I'm repeating. In the Kubernetes container do not get IP address. Pods get IP address. That means if you have a multiple container in the pod, all containers in a pod share a single IP. Yes. Please read that. Here, pod get IP address. Pod has a container. Pod may have a multiple container. All containers is accessible through the networking IP address of the pod from outside. And who assigned the IP address to the pod? Kubeproxy. So, because of kubeproxy only, load balances across all pods is possible. How it works and all, I'll explain you tomorrow or day after. But kubeproxy is the third component which helps the pod networking and load balancing done. And that was the problem with the containers technology with the Docker, solved by kubeproxy. Okay. At the high level, this is the functionality of the kubeproxy. So guys, overall, this is the master, this is the node. So Cubelet, who's the main Kubernetes agent, container engine, it can be Docker, Rocket, or anything else also. Kubeproxy, Kubernetes networking, and guys, this is a consolidated components image and the communications. You can look at this. See that arrow sign specifically. Cluster, store, scheduler, and controller manager. Again, they talk to API server. That arrow is missing here, but in the last image I did this. So guys, are you getting comfortable with it, how Kubernetes works? I will discuss a little bit more, but so far, whatever we discussed is okay for all of you. Are you getting it? Any confusion, any questions?
One question, on the pod, right? A pod will be aligned with one IP address, right? And a pod can have multiple containers.
That's correct.
For example, it has two containers and two applications running on 80 port. Okay, now the pod, right, has the 80 port. So how again we will end up in the same problem, right?
That's a very good question, sir. But here what will happen, if you want to run two Apache containers, then you should be having two pod actually. Remember, pod get IP address. So even though if you run that two Apache and change the port also, you'll not be able to access that second one through the load balancer, no? Because network load balancer requires the same port, different IP address. So in that case, you do what, two containers, two pod. And pod is just a wrapper, it's not consuming any CPU and RAM. So pod, two container of Apache, two pod will be there. But, if you want to run one Apache, one Tomcat, one MySQL, Tomcat 8080, MySQL 3306, Apache 80, then you can keep it in the one pod. I'll discuss that one little bit later also, but that was the right question.
Another question, right? So for the cluster, right, we know like how to scale up the containers. But in a cluster, right, the nodes are a virtual machines.
Yeah.
So we will how we will be scaling the virtual machines actually, or it will be a fixed number of machines in the cluster.
Yeah. So understand that Kubernetes is a container orchestrator. It will not. Just a second, sir. I got a little bit some problem in my face, and so it was bleeding. Yeah. So here I was saying, anyone, sir. Let's say I'm a minion, and I want to become your worker. So how can I become a worker? I need to run myself Cubelet. Remember, the moment Cubelet runs, and the moment the Cubelet no API server, and the moment node a master approves that through the certificate, the node become a part of the master. So these are the 3 steps. Step number 1, run Cubelet. Step number 2, request to the master. Step number 3, get a certificate. You are a part of the cluster family. That's all. Now, this can be done in a various ways actually. What you can do, you can have a virtual machine, Cubelet automatically installed, certificate already installed. The moment you start the VM, automatically is a part of the cluster. That's the one thing. Now the question is whether Kubernetes can add a worker. Kubernetes no need to add a worker. Remember, any node decide who should be the master, not the master decide who should be a node. If any node which is having the Kubelet running and certificate of the master is there, that will become a part of the master automatically. Cluster automatically. So here node decide. Now how can the node decide? So your question was something like, let's say there are 4 machines running and I have got the huge load. I want to make it 4 to 10 machines. How can it be possible? So that is, you can control through the app. Let's say if you are on AWS, you can control through the auto scaling group, where you can keep watching the utilization of node CPU and RAM, and then if it is meeting to your threshold, you add 1 or 2 or 3 more instance. That's adding the machines is the one thing, but whether that machine is a part of the Kubernetes cluster is the second thing. So adding a machine, creating a new machine is a part of the cloud services. Whether that machine is a part of the Kubernetes cluster or not is decided by Cubelet. That can be automated in a VM itself. So did you get an answer now for that your question?
Yeah, I got that.
Yeah. So guys, this is the communications happen. So there's some questions in the chat also. Let me read this. So the question from Rajesh is, so master can be a multiple, right? So node communication to all ports, node communication to all ports, network communication, see here. Master, when you say for SCA purpose, it can be a multiple master. So always one master is available at any cost. So node communication to all ports. So that was a networking requirement. So all node, when I say node means through the any node, you can ping to the any, across the any pod, any node which is running. That was a networking requirement. You can get it done through the QProxy. Now, second we have a multiple master, right? Does that node communicate with all the masters? Yes. That is there. That's the requirement because of the QProxy. Little bit over the QProxy I'm not covering. I will cover after half an hour because something is missing. I will cover. But yes, here the requirement of networking in Kubernetes is all pods should communicate with the all nodes which is a part of the cluster should communicate with all the pod and without a NAT. That was the requirement. Who will make it possible? QProxy. Now, if you have a multiple master, that will be communicated as well. Because multiple master is a part of the cluster also.
One more question, the cluster will have master, and behind that the node which is ready to handle the customer request, right? So all the customer requests will land on the master, or how that will work?
No. Customer request in terms of API request, right?
Yeah, I have API. Okay.
Master is not doing anything, no. If you look at the architecture, master is not doing any CPU intensive work. Master is just scheduling the work through the scheduler to the node worker, right?
So that is responsible to generate more parts based upon the maybe the capacity.
Right.
But my point is the capacity will vary once we got more requests. Let's say I have APIs, microservices, services, clients are using it. Okay, what will be the gateway? So the gateway for those services will come via master, or like?
No. Okay. I understood that maybe your question. Let me tell you. First thing is all about. First thing in the today's session of Docker, we learned how to run applications cheaper and faster through Docker. Okay. Now we got greedy. We become a greedy. We thought, okay, Docker we are using to run application cheaper and faster. But we want to run this in the production, so we can save lots of cost and it can be more faster. So then we started using Kubernetes. Kubernetes is the orchestrator, remember. It's just the orchestrator. It just schedules the container through the pod to the different nodes. It's doing nothing. Now, your question was, how can I control which node should have how many pods, and how can I set that this node should not be having this many pods? Those are the things you can control through the Kubernetes also, and different way also. So there are multiple ways are there. So you can, by the way, you can write a scheduler. Scheduler, remember? Scheduler who schedules the work to the node, depends, and it has affinity, anti-affinity, constraint, and resources. Scheduler, I am talking to scheduler. So scheduler, if you set the rule saying that, okay, I want to create a pod only till that the CPU is 70%, 70, 80%, those are the setting configuration you do that. But right now I'm not getting into too much of complication because your understanding will get, problem. So that's the reason I'm not deep diving. Slowly once we start using it, we'll get it. You can write your own scheduler also. You can write your own rules also. Which pod, which node, how many containers, how many pods, all these secrets are set to the combination problem.
Okay, I got it.
Yeah. Okay, so guys, now let's move on. So here, so guys, let's understand that what is worker nodes. So guys, worker or nodes are convenience we have three components, Kubelet, and container control, which is Docker. So Kubelet, which is monitoring API changes, responsible for pod life. There is a pod life cycle means creating a pod, running the pod, deleting the pod, and all. Here, a pod, get, and stuff like that. Nodes is doing proxy is doing the networking services. Network proxy IP table implement services, routing traffic to the pod, load balancing also it is helping you. Container runtime, you know that right now, so you know that container runtime like a Docker and all, what it can do. Okay, so that guys, this is your. We do have other components also like a DNS, ingress and dashboard and all. But right now I'm not complicating, but yes, you will be having many other components also. But these are the add-ons actually, additional features. Now, so we have understood master, we have understood worker also. Now we have to understand declarative model versus desired state. What is a declarative model? Let me show you the first architecture. Look at this image. So we got to know everything about the master. We got to know everything about the node. But the one which is there in the JSON file, which is in your laptop, that is pending. Because that's the most important one, right? Whatever you write in JSON or YAML, that is been sent through from your laptop using kubectl to the API server, and the rest of the things is happening. So we need to focus on this JSON or YAML file, what you write. That is what we are going to focus now. So let's discuss, guys. Declarative model and desired state. Guys, what is a declarative model? So earlier, when we wanted to get some task done, remember, earlier means 20 years from now, by the hardware, then you used to write a program, languages, compiled languages. Okay. Then we decided, no, the compiled language like a Java and C++ is taking huge amount of time to write a software. Then we migrated to interpreted languages like a PHP, Python, Perl. Then we realized that, okay, these are also taking time, and same time, more or less everyone is writing the same functionality. Everyone, mailing functionality, chatting functionality, UI functionality, validation functionality, cache functionality, this functionality. More or less every software needs something similar. Then we got into the world of declarative language, not interpreted, declarative. When program has been written, it's running, it's there in your environment, just declare it in the declarative languages. Whatever you want means that's whatever your desire, declare it, and then you get that functionality. Simple. So nowadays, if you look at the declarative model languages, earlier XML used to be very popular declarative language, where you declare and then things will get done. But nowadays, from last few years, we got the JSON and YAML very popular. Why is JSON and YAML very popular? Because it's a fast. That's all. It's a fast over the network. Okay. So now we started writing declarative languages in the JSON and YAML. But actually, now everything is getting done with the help of just declaring in YAML and JSON. But you need to know what you want to declare. What do you want? You have to tell me, right? If you don't tell me what you want, how can I give it to you, that functionality? So you have to desire. You have to have a desire, right? And in Kubernetes session, having a desire, knowing the desire, learning the desire is just the only session which you have. Rest of the things is, you know that Kubernetes hides complexity. Kubernetes hides abstraction. All these things. So you need to know what you want. So do you know what you want? So maybe something which you want pod. So you want the pod of what? Nginx. How many pod you want? 3 pod. Where you want? So you declare in YAML or JSON. Okay, fine. And through kubectl, you send it to the API server. And then what happens? You know that API server will store in the KB store. Controller will check whether do you have a 3 Nginx pod in my cluster or not. It will report back to the API server. If it is not there, scheduler will schedule that 3 pod to the cluster, and you got the 3 pod. Did you understand that now flow, entire flow? You got the 3 pod of Nginx. Did you understand that, guys?
Yes, sir.
So guys, you got the 3 pod, but suddenly what has happened? There's some problem in the node. One node disappeared because of network issue, hardware issue, software issue, this issue, that issue, I don't know. It got disappeared. So remember, your desire was 3 of Nginx pod. Now you have a 2. Now this was reported by controller manager saying that, boss, I could only find 2. So controller will send this information to the API server, and API server will say, okay, let me check. And they check that, okay, in my database I had a 3, but right now you are reporting 2, that means 1 is missing. Go ahead, scheduler, and create one pod in any of these available nodes. And we got 3, third. How it works, you know that very well. So here, who's doing the desire versus actual matching? Not you, Kubernetes. And that is how Kubernetes will help you to manage your desired state. Did you understand that? Hello? Hello?
Yeah, Rajesh, you are able to hear me?
Yeah. What is your question?
So the manifest file of 3 SecOps or FinOps with 3 layers of each ops and change.
No. Kubernetes will not manage nodes. Remember, Kubernetes responsibility is to manage the number of pods. Having a node is a part of the cluster of node, is a part of the Cubelet job. I said, right, Cubelet runs. If they have a certificate, they are a part of the worker. If the node decides who should be a master, not master decide who should be a node. So now let's say, earlier you had a 3 node, now you have a 2 node. So now the remaining pod will be created in the node which is existing. Now one situation you might get, let's say the node is not capable to handle the new pod, existing node. In that case, those new pods will get into the pending state. But more or less what happens in the cluster environment, 10 to 50% of resources you'll be having where you can create and place the node. Here it's like a 2 or 3 nodes we are talking about. In the production we have a 20, 30 nodes actually. So somewhere you will have some buffer where you can create a pod. Scheduler knows everything because each node will keep on reporting about their availability to the scheduler, and scheduler has all the information actually. Okay guys, so this is how the Kubernetes works. So what you want to know? Ultimately what you want to know. So guys, in this remaining session, your job is not to do anything but to know what to desire. Again, I'm repeating. In the entire session, your job is to know what you want to desire. And whatever you want to desire, whatever you want, express in YAML or JSON, send it to the kubectl. kubectl will send that to the API server. API server will store that in the KB store. Controller will keep reporting back to API server about the desired mismatch or not. Scheduler will schedule the work to Cubelet. Cubelet will get requests from this API server through scheduler and do the work with the help of the Docker engine, and networking of the pod will be given by the kube proxy, and that is the entire game which is running on day and night without stopping. But what you need to know, what is your desire, and that we call it in Kubernetes API objects. So you need to know pod, you need to know controller, you need to know services, you need to know storage. This is not an exhaustive list. These are the key players. So in Kubernetes remaining sessions from tomorrow morning onwards, you need to know what are the desire you should have. Before that, we'll understand what is a pod, how to set up a cluster, how to add a master, how to add a node and all these things. Authentication, authorization, all stuff like that. Guys, did you understand that?
Thanks for watching. If you liked our Kubernetes session so far, please enroll for our channel membership $399 plan to get access of all the parts. Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.